Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a group that every week or most weeks we do either online sessions or in-person sessions to help people get into Python and also to look at some of the topics in Python and machine learning that even experienced people can find useful. Next week we've got our in-person session, and I'll be repeating this logging details. So if you have any questions that come up tonight, you can ask them either tonight or you can bring them along next week to Queen Street Mall at Brisbane Business Hub. So tonight we're going to be looking at logging. Logging's not a very exciting topic, but it's something that every Python programmer should do. Just put logging statements through their code so that it helps them to find problems that are going wrong later on. I found there's a few interesting parts to it, so hopefully I'll be able to spark your interest. Now we're doing it tonight using Google Colab, which means you don't need to have a Python installed on your computer. You can just run everything in Google Colab, and Google will provide you with a server running Linux that you can run your Python code in a Jupyter notebook. So the link to the Google Colab is just below the video that you're currently watching, and it's also on the meetup page. So I'm showing you the meetup page here. So if you click on that, that'll take you to the Colab workbook. Now if you've got any questions, you can send through to Learning to Code channel in our Slack section, and there's instructions on how to get onto that down below. You can also send questions in through the live chat on YouTube. So I'll be looking for that. They do get censored if you put in links or anything, so but hopefully I'll see them if they come through. Alright, so we've got our the Google Colab notebook that I wrote. Changes will not be saved because you don't have permissions to do that. So I suggest you copy it to your drive. You'll need a Google account to do that, and then you'll be able to make changes to it. So I'll do that as well. I'll copy it to my drive, and I'll make some changes as we're going through. I'll even share this link with you so that you can see any of the changes that I've made tonight. So I'll make it anyone with the link is a viewer. Copy the link, done, and I'll put that here. And I'll send it to Slack as well. Very good. Okay, so if you haven't seen Google Colab notebooks or any Jupyter notebooks before, they're just a series of cells. Each cell can have either code or text in it. This is an example of a formatted text cell where I'm just saying what we're doing tonight. We're going to look at how to use logging and loggers, how to configure it, how to set up handlers, and also doing some bash code. So bash is the Linux shell, is a Linux shell that you use when you're running stuff from the command line, and it has different inputs and outputs, standard out, standard error, and we can redirect them to files and other places. So that'll be what we're dealing with tonight. Here's the links. We've got a GitHub link which has got all the sessions that we do, and there you can find links to other YouTube videos and Google Colab notebooks that are to do with them. Here's a few references that I used when I was putting together this stuff, so you might find them useful as well. Most of them are just the standard Python docs for logging. Alright, so let's get started. So in a Google Colab notebook, you see right up in the top right here, we've got a connect button. So if I'll click on connect, and that'll tell Google to set up a server for us, and it'll give us a certain amount of drive space and a certain amount of RAM. When we finish, that server will be shut down and deleted. So don't try saving anything there that you want to keep, but you can save stuff in your notebook here, and that'll, if it's on your Google Drive, because you've saved it there, then that's where it'll be saved, and you can then open that up at a later stage. All right, so what is logging? Logging is just sticking messages in your code so that you can track how your code's going. So for example, here I've got a loop for I in range 5, and I've put a print statement in here that just says I'm in the loop, I'm in the for loop, and then I print when I gets up to 5, I'm going to print something that says we're waiting for I to get to 5 to do an important task. All right, so we run it just by pressing the play button here, or you can see you can press Control Enter is the keystroke to do it, and you can run this on your computer as well, and it'll all be running on servers that Google have set up. And here's the output. It says I'm in the for loop, I'm in the for loop, in the for loop, but I never get we are waiting for I to get to 5 to do an important task. So there's obviously something wrong with my code. I'm not really sure what it is, and I've got some logging in there, but it told me that it went through the loop 5 times, but it didn't give me much other information about it. So it's useful when you're logging to try to put in some indication of state of what different values of variables are. And I like to use f-strings for that. So f-strings are a reasonably new feature, only entered Python in version 3.6, but they've been so popular that everyone's just converting all formatted strings over to f-strings. And this is a particularly good one. So an f-string, you just start with an f out the front, and that means that anytime it encounters curly braces, then it will look inside the curly braces and evaluate it. And the special version that it wasn't actually available in 3.6, I think it was about 3.8 when it came available, is if you put an equals sign, it'll actually print the variable name and the value of it. So it's just perfect for what we want to hear. We want to see what the value of I is in each time we run through the for loop. So now if I run that, I can say I'm in the for loop and I equals 0, I equals 1, I equals 2, I equals 3, I equals 4. And now I can see what my problem is. I forgot that range 5 takes you up to, but not including the number 5. So I is never going to equal 5 in this loop. So that's why this print statement never happens. We are waiting for I to get to 5. Now I'm assuming you've seen a lot of these things before, like f-strings, but we are a beginners group, so if you haven't, just let me know and I can give you some more information about that. All right, so that's using printing for logging. Problem with print statements is that, you know, once you've worked out the problem, we worked out the problem here, every time you run this bit of code, you can have all these print statements putting code out onto the console. And so what we prefer to do is use the logging package. It's a standard library that comes with Python. It was actually copied off the Java logging packages, and so it's got the same sort of structure as the Java ones. And one of the things that Java had was a lot of the function names and variable names all use this camel case way of labeling, which is not really a Python standard. Unfortunately, this got implemented back in Python 1, and so many people started using it that it was too late for them to make a change. So we're stuck with camel case when we're using logging, but as long as you know that, then that's not a problem. All right, so logging, and we're going to do a basic config, which is just going to set up the logging to work here. It'll for initially the default is a level of warning, and it'll by doing this it'll change the handlers just to have it going out to the standard console. Now this is one of the confusing things, and one of the traps that a lot of people, and I've been really confused by it myself. I've tried running logging basic config and nothing's happened, and the reason for that is that logging .basic config was designed to only ever run once in your code. Therefore, if you want to run it a second time or a third time, you have to put false equals true into as one of the parameters. And you think, well, I haven't run it. Why isn't it working here in Google Colab? And I think when Google set up their Colab notebooks, they must run the config themselves, which means it's been run. So it just ignores every time in Google Colab you say basic config. So I'm going to put false equals true in there, and then it will work. And if we don't run that, the output will go somewhere, but it won't be going to the console, so we won't be able to see it. Alright, so let's run this code. So it's pretty similar to before. We've got an F string here which is saying where we are. We've given it a level of warning, and this time we're just going to go to 3 because we know it actually gets to 3 and we want to see something a little bit different. And we say we'll give that a value of error, and we'll log it there. We're waiting for I to get to 3 to do an important task, and that's what we see in the output. So now we're seeing these F strings being printed out with their values evaluated, and we're also seeing a bit of extra information. We're seeing what level it was when it got logged, and we're also seeing the name of the logger, but we'll get onto that more later. Okay, so these are the levels, warning and error, that we've used, and there are 6 predefined logging levels, and they're just integers. So 0, 10, 20, 30, 40, 50, and you just use different ones for how important do you think the logging message is. So if your message is just for debugging, so it can be quite verbose, then you set it at debug level, and then you'll only see it if you've got the level set down at debug, which will be lots and lots of debug information coming onto the screen, and you normally have that turned off. But things like warnings and errors and criticals, they're all really important, and that's why the default is warning. So anything from warning up is shows by default, and these ones don't. You don't ever actually output to not set. Not set's just a one that's there for, I don't know, I've never actually used it. Alright, so challenge 1, rewrite the function when3 to log at debug level in loop, and I've set you a box here that you can type it in, and so you can now stop your video and have a go at it, or you can do it while I'm going to do it now in front of you, and see how you go. Alright, well, let's solve this issue. So we've got a function called when3, and then we call it. So I'm going to copy that function and paste it here, so that'll redefine it, and we want when3 to log at the debug level in the loop. So this one is in the loop, so I'll just change that from warning to debug, and info level when I equals 3. Okay, so let's go info level. Okay, now I'm going to run this function to see how it goes. So I press the play button, and I get nothing out, and that's because the default logging level is warning, and debug and info are lower than that. Okay, so here's a solution. It was pretty simple, so there's the solution is exactly the same as what I typed in. Okay, and this is the output, the result. No output, but we can change the logging level. So here we can run our basic config to configure the logging to use debug level, and then we can call the function again just by the function name and the parentheses, and we'll see what happens. So this time the logging level is now debug, and I get all the debug and information coming out, but if I set that level to warning, I didn't get anything. So that's how you can easily turn logging on and off, and it doesn't really hurt your code much if you've got these logging statements in there. That it'll slow it down a fraction of a millisecond, but it's usually a good idea to have them in there. Alright, so now let's set the logging level to info and run the same code. And this time all the debugs are missing, but we just get the important info one saying we're waiting for I to get to 3 to do an important task. Okay, now at the moment you've seen all the logging coming out to the console, but sometimes we want the logging to go to a file. So for example, if you're running a Python program on a server somewhere, you want all that logs to go to a file so that you can go back later and look at the file rather than having to be logged into the server the whole time watching the console. So basic config gives us the possibility of doing that. We can just specify a file name and a file mode, and once again force equals true. The file mode can be either an A for appending, which is the default if you don't specify it, or W to overwrite. So every time you start the program or the script, it'll overwrite whatever log file is there, or if you're using append mode, it'll just add it to the end. So I'm going to overwrite, and we're going to run and see what we get. So we've got nothing came to the console. So there was no logging happened in the function when3 to the console, and there was no logging here. We put a logging statement at the end of this cell, logging.warning, to say that the script had finished, and we didn't see anything there. However, there's been a file that's been created, and I can view that using this bash command. If I do the exclamation mark in Jupyter Notebooks, I can now run bash commands, and cat is a bash command to have a look at files, and I can run that. And here we go, I can see all the logging that happened. It all went into that file, and it says we are waiting for I to get to 3. This is the logging that happened in when3, and then we got this warning, root script finished, which is that one there. Alright, now see this folder here on the left, it's called files. You should have that on your notebook as well. So if you open that, you'll see that we've now created a file called logfile.log, and you can double click on that to see what's in it, and you can see over here on the right there's the contents of that file. So that's another way of looking at the contents if you don't want to use cat. So cat actually stands for concatenate, and so it's useful if you've got more than one file. You can concatenate them all into a whole bunch of text. Alright, so let's set the logging back to the default. So get rid of this file handler and just have it coming to the console. So I'll do that. And now we're going to show another way of logging. So remember, we've been doing things like logging.debug and logging.info, and each one of those has got a number like 10, 20, 30, 40, 50. Well, you can actually do log.log, and then the first parameter of that is that level. So you can put in 10, 20, 30, 40, 50, or you can actually even just put in any other integer. So for example, if I want to go from 1 up to 32, it'll run this logging.log 32 times, and each time it'll have a different logging level. So let's see what happens when I run it. So when I run it at the logging level of 30, it says this was a warning. So it's actually converted the number 30 back to the name warning. When I run it at 31, it doesn't have a name for it, so it just calls it level 31. And at 32, it called it level 32. Level 29 didn't even display, and that's because we've set the level here to say that the level is logging.warning. So all the ones from 1 to 29, they don't display because we say hide them for now, we're not interested in them. They're only just there if we're really trying to do some fine tuning in the using the logs. Okay. So we've been logging using the logging command, and logging actually creates a logger called the root logger, and that's what this root is. Every time we print, it says the name of the logger that you've just used is root. However, you can create loggers with other names. So here's an example of creating one just with the name my logger. So now when I run these logging commands, and I've just done 5 different examples at different levels, we see the logging level that got logged at, and we also see the name of the logger at the time that it was logged and where it was logged, and then the message. Okay, we've got some Unicode characters in there just to show you can log with Unicode characters as well. Okay. So these names can be anything. They've got special character, special properties if you use dots in them. So they will actually propagate up, but we'll go into that more later, based on positions of dots in the logger name. What a typical design pattern is when you're coding is to use the name of your current module as the logger name, and that allows you to turn just one module on or off when you're debugging the code, so you don't get logs from everything happening. And when you want to turn on debugging, you can just turn debugging on for one module rather than the whole Python package. And there's a Python special property called dunder name, so double underscore name. That is the name of the module, and so if you put this line of code at the top of every one of your modules, then you'll be able to log using that design pattern. So for example, here we've said logger equals, or the logger name is going to be whatever's in underscore underscore name underscore underscore, and that is actually in a Jupyter notebook, so it's not really useful here, is dunder main is the name that is stored in name. So not a great name for here, but if you're doing it in your Python modules as part of a package, then it's really useful. Okay, so challenge 2, rewrite our function when3 to use a named logger rather than the root logger. Okay, so let's go copy, once again, have a go at this yourself. This is when you really learn, is when you just write some code, and these ones are quite simple challenges. So we'll put that in here, and we've got a named logger up here. Logger equals logging.getLogger name. So let's just use that one. So rather than logging, we just call it logger. And we run that. And nothing showed because we must be on warning messages. Yep. All right. Now we've got a question here. Do you need to load the dunder package if you're not working in Colab? No, there is no dunder package. So this double underscore name double underscore is available in any Python script, and it's also available in Colab notebooks and Jupyter notebooks. So it's always available to you to be able to use double underscore name. All right, here's my solution, and once again, it doesn't work, but what you can do once you've got individual named loggers is that you can set the level on the individual loggers individually, and that's how you do it. Logger.setLevel to debug, and then we can run it again, and this time we get all the debugs and infos coming out with the name main there. Okay, logging an exception. So this is really the last thing that you're going to need to know. So this is stuff that you need to know to program. Like this is stuff you should be remembering. And then after that, we'll go on to some things that you just need to look back as on a reference, because you'll only do them rarely. And one of them is logging an exception. So sometimes you get an error. You've caught it in a try except, and you could do some message like, wow, something really went wrong, but that's not going to tell you a lot about it. But the logging commands allow you to pass in this extra parameter, exception info equals true, and when you do that, as well as the logging message that you've said, something actually even more useful will come out, which is a stack trace of the where the error occurred and what the error was, as in the name, 0 division error, and the description, division by 0. So, and this is saying it's in cell line 2, so it must be 0, 1, 2. So it happened in that line, and it's a division by 0 problem. So that's these stack traces are much more useful when you're in your code and you've got functions calling functions, because each of those calling functions will be listed in the stack trace, so that you can, the problem might actually be in one of the places where it's calling the function that's providing bad data, that when it finally gets to that line, it causes a problem. Okay, so that's the summary. These are things you need to remember. Every module, create a logger just using that, and then you just pepper it all through your code. Just critical statements if it's something that's about to terminate your application. Error if something's gone seriously wrong, but you can recover it from it. Warning if there was some issue that is possible to cause another problem later on. Info for information which may help someone understand what's going on, so that wouldn't normally show, and debugging for verbose information. And the third thing to remember is your exception info equals true if you're logging inside an exception where you've caught the exception, and so you can see the stack trace. One thing I didn't mention, if you look at other people's code, you might see the old way of formatting strings in logging statements. They put a message at the beginning with lots of percent symbols through it, and then they put all the variables after it as the parameters to the logging message. But because f strings are so powerful, I don't think you need to remember that. It's just, or even know it at all. You can do everything you need with f strings, and probably better than the old ways of doing it. Alright, configuring logging. Now this is surprisingly difficult and takes a while to get right. What the ideal situation is you write your code, and you write it in such a way that it's got logging statements all the way through, but it can be, the logging can be configured by your DevOps guys. So the guys who are deploying your code, they want to be able to set up the logging. They haven't written the code. They don't really want to get involved in it, but they want to be able to say where the logging goes. Like they want it to go to a particular file on their drive somewhere, or they want to, they've got this code that they didn't write, but they want to turn on some extra information to find out where it's not working. And so they're the ones who want to be able to do it. So if you can set up your code that way, then that's the ideal. So we've seen using basic config. That's I didn't want to. Basic config is great for simple demos like this, but you don't want the DevOps guys to have to edit your code and put basic config statements all through your code. Okay, so there was another one called file config. It enables you to create a config.ini type file configuration, a configuration file that you can use, which is sort of getting good, but it's no longer recommended because it doesn't actually allow the full range of configurations. So what is recommended these days is dict config, and I've put a link here to the dict schema, which allows you to that shows you what you need to provide in the dictionary that you're going to use. That's going to configure the file, and the dictionary, you can store it in a file itself, usually in a JSON format, and that way people can edit that file in JSON, which is a well-known format, and they can configure the logging for your application that's running. So things that you put in is your formatters, which basically shows how the data's how your log statements are written into the file. Filters, which are a bit more complicated, we'll get onto them later. Handlers, which say where the output's going to go. Is it going to go to the console, standard out, standard error? Is it going to go into a file? It can even go to an email, it can go to Slack. There's handlers for a lot of things. Loggers, you can set up different properties of different loggers. So if you know there's a logger in a particular module that you want to turn on debug mode, you can put that in the configuration file, and all the other loggers will just inherit from root, maybe at warning level. Incremental, so the default is false, so you want to do that, set incremental if you're adding extra handlers. If you're defining all the handles, then you just leave that as false, and it will replace whatever handlers are already there with the new ones. And disable existing loggers, the default is true. They probably think now the default should have been false, but it's too late. Everyone's assumes the default is true, so you'd be pretty frequently that you would set disable existing loggers to false. Alright, so let's create a dictionary that sets this up. And I've used an example. I think it's probably come from one of these references that I had, the logging.config reference. So I've set disable existing loggers to false. And so it'll replace existing handlers because we haven't said anything about incremental, but it won't disable any existing loggers. I've created two formats with just names that I made up, so I just called them standard and error. And they're pretty much the same. They've just got S for one of them and E for another as at the beginning, and then I've said the time the logging event took place, the level of the logging, whether it's warning or debug, the name, and that's the name of the logger, and then the message. Because I've used this f-string type format, I have to say in my dictionary that I've used style equals curly braces, because it's assuming that you'll normally do this using percent formats, but I don't understand percent formats, so I like to do everything using f-string formats. Okay. Now I've set up some handlers. I've got one going to a file. It makes it easy to do a rotating file, so it'll get to a certain size, and then I'll just replace that file with another file, so none of the log files get too big, and you can't accidentally fill up all your drive space, which is a real problem with log files. That if you do logging to try to find problems, and yet it can actually create problems because you can fill your drive up with log files. I can set these names here: file handler, console, standard error. They're just made up names that you make up. But inside it, these are the important things. So class is saying I want to use a rotating file handler or a logging.stream handler. They're the important names that you have to use the proper class names there. Okay, and like you can even send emails on if a particular error happens. So you get an error in your inbox to say there's been an error in one of your programs that you've been running, so you don't have to keep checking the logs all the time. because it's actually comes looking for you. Alright, so we're going to set up the root logger, which everything inherits from, to be level info, and it's going to go to the file, to the console, and standard error. I've also got my logger, which I'm going to set to level debug, and it's going to have the same three handlers. Alright, so that's a dictionary. I'm going to store this in a file as JSON, but I've done it as a dictionary because you probably don't understand. I mean, I'm going to assume you understand dictionaries better than JSON because you're in a Python course rather than a JavaScript course. So I'm going to create this logconfig.json. So if I run this cell, I've now created a logconfig.json, and you look at it over here on the right, we can see what it looks like. It actually looks very similar to a dictionary. The only difference is because it's JSON, we've got lowercase f for false rather than uppercase F as in a Python dictionary. And that's everything else is pretty much the same. Alright, so I've created a config file. Oh, here we go. I can use cat to see what it's in there. And now I can use that dictionary to configure my logging. And so I'm going to load it using the JSON library and convert it into a dict, and then the dict is going to be used as the configurator to configure things. Right, so I run that. Now how do I know I've got it right? Like there's a lot of stuff happening in that config file, and it's pretty hard to know get it right the first time. And this is one of the big things that I think is missing from the Python logging library, is a way to inspect it that you can actually easily see what configuration you've created. However, a third-party library called Logging Tree does that quite well. But we need to install it, so we'll run the bash command here, pip install logging tree, and that'll install it into our Python that's running on our Google Colab Linux box. So we've got logging tree version 1.9, and now if I run it, I can import it. Now unfortunately there's quite a lot of information here. I'll just close this. So this is saying we've got a root logger. It's basically got no name, so they're just shown double quotes with an empty string in there. Remember we said that the root logger is info with three handlers: rotating file, stream, and stream. And the rotating file actually had a level of info, and the consoles were debug and warning. So that's the standard console, and that's the error console. And then there's all these other things. And where have they come from? Well, that's because we're running in Google Colab, and Google Colab's pretty much got all the Anaconda libraries installed, and so each one of them has got some sort of logging setup. And so the Python imaging library in the pil.image module is set up, and logging.tree actually shows very nicely how the propagation happens. So it's saying the level's not set for this module, so it'll inherit info from root. And remember, see root's up here, it's got info, so pil.image has inherited that. And similarly, PNG image plugin also inherits. And so here you can see all the different libraries and all the different setups that we've got, and you can see how the dots are used. So these are the logger names. Remember, we create the logger name, and then that logger will send stuff out on error if it's got a handler, and then it'll propagate the error message up to here, and then that will also if it's got any handlers, that they'll also be used. So it's showing the propagation that's happening. So there's a lot of information here. This is why I like using virtual environments, because I don't have all these libraries that I'm not using. Here's the one I'm more interested in, my logger. So my logger we've created, and it's, remember we put three handlers on that, rotating file stream and stream, and we set the level to debug. Alright, so let's see how that goes. So challenge 3, send info and debug logs to the root logger and to my logger, and check the logs in the file. Okay. So info and debug, let's go. So logging, I can just log straight to using logging command, and then that'll be the root logger. And we'll just say, I'll just call it my root info. My root debug, and then my logger, well, that's in logger equals not equals dot info my logger info So we go 4 messages at different levels and to different loggers. So what happens when we run that? So we get my root info going to the root logger. We get my logger info going to see, we've got the wrong I've got the wrong name here. The my logger log, we've now created a new one since then that's called main. So I got that bit wrong, but that's all right. We'll have a look in the solution. The solution actually gets the logger with my logger. So you just create a new one. It just creates a new logger with a new name. You just make it up. So let's run the solution, which has got the loggers a bit better. So root logger, it just gets logger without a name, and that'll be the root one. And my logger, it gets the logger using the name. And then we do the same messages, and it's all comes out nicely, except there's a bit of duplication happening. The one that we sent to root, that just came out on its own, but anything we sent to my logger came out twice. The one that we sent to main logger up here, that only came out once. So there's something about our configuration that is duplicating these messages that we're sending to my logger. Okay, and if you remember, when we looked at my logger up here, we'd actually configured some handlers on my logger, and then it propagates up to root, and root's also got handlers, pretty much the same ones. So it's going to log them as well. So we're getting 2 lots of logging happening there. So the problem is that we've defined some handlers for my logger. So I've just got some code here that will remove those handlers. Normally you do it in the config file, but you can do it programmatically, and this is how to do it programmatically. And then we run solution 3 again, and that got rid of those duplicates. So we just used the remove handler command to remove any handler that it found. And if we ran the logging tree again, we'll see that those handlers aren't there. Okay, challenge 4. Send a warning log to root logger and to my logger. Okay. Well, there's nothing really special about that, so I'm not going to bother typing it in. The solution's just here, root logger.warning, a warning from root, and my logger.warning, a warning from my logger. Okay, so we run that, and we're getting duplicates again. So the ones from root are now duplicated, and the ones from my logger are also duplicated. And the difference here, so we'll think about why we might be getting that problem. One of the clues is that they're not exact duplicates. One of them starts with an S and one of them starts with an E. And remember, we created two different formatters, one starting with S and one starting with E, for our standard and our errors. And they're so we've got one handler for the standard is going to what's called standard out, and we've got another handler for anything that's an error or warning, and that's going to standard error. So warnings and errors are actually going, and critical are actually going to two different places and getting logged, so we're getting duplicates there. So the challenge is, how do we not send warnings and errors to standard out, but do send them to error? Because when we set a level, it just always sets that level and anything higher than that. It doesn't have a way of saying anything between these two levels. So to do that, we have to use filters. And so here's in Logging Cookbook in the Python docs, it tells you how to make a filter. This is the code that does it. So it's pretty standard code that you're going to need, so just copy and paste it. I can go through with it, what it's doing, but it's really this should be fine. So we can define that filter. If you want me to explain what's happening, I can do that, but it just is letting us use a function that will return true if the level number is less than a level. So then we can put an upper level on any of our loggers. Okay, so I want to create a config file here. Remember before I created a dictionary and then wrote a Python program to convert it to JSON and then save that JSON. Now I'm going to use bash to just save the JSON directly. So you can see there's a false there with a lowercase f. So this is something I've only just recently discovered. In Google Colab, you can put in %% bash, and now every other command that comes after it will be in a single bash shell, which means that we can have multiple lines of bash happening. So in the past, where we used the exclamation mark, it all had to be on a single line, but this lets us do both. Alright, so bash allows us to do redirections. So remember, we could have a look at a file and it would send the output to standard out. But now we can do things like a less than sign says we can take standard in from a file. So we can, which I mean for the cat command it's going to mean the same thing, because the cat command will use a file name. But what's more important, we can send the output to a new file. So we can cat one file and send an output to another file. So it's a way of making a copy of a file if we need. And that, if it's a single greater than sign, then it will it's like write mode, so it'll overwrite an existing file or create a new file. If it's double greater than sign, it'll append to any existing file or create a new file. Remember, so this is standard out. We've also got the same things for two greater than, which does the same thing for standard error. So we can, but we're not looking at that at the moment. We will later. Now here's an interesting one. We can take the input using double less than signs, and it will take in everything between some delimiters, and we can make up the delimiter ourselves. So I've chosen EOF, which is a common one because people think of that as end of file. But whatever you choose, it has to be something that's not in the file itself that you're going to create. So yeah, you just might find something that's not in there. So EOF is not in this text that we want to do, so bash will just keep taking all this text as though it's a file. It's called a here doc until it comes to EOF, and I go, all right, that's the end, because I started here with EOF. So it takes that in as though it was a file, but in fact it's just a bunch of text that I've typed in on the console, and it's going to put that out to logging config with filter.json. So if I run that, I've now created an extra file, logging config with filter JSON, and if you look at what's in that, you can see all that text. So that's a good way of creating a file from the command line. And I use this in all my documentation when I'm writing scripts to create files. I do it this way so that I can then just copy and paste from my documentation and run it like a script, and rather than having to create all these files and say nano and then the file name and to run an editor, and then I've got, once I'm running the editor, I've got to remember how to get out of the editor, but this will just create the file automatically for me. Alright, so that was a quick briefer on bash redirections, and we'll be going to use a bit more of that later. Okay, so we've created this oh yeah, better look at what we've done. So what's different about this configuration is we've now set a filter. So we want a filter called info and below. It's going to call the function in main.filtermaker, and it's going to pass in an argument. The level is going to be info. So it's going to include info, and everything below is going to return a true. So we can use that filter when we're using our standard out. So we can put it in here. We want this filter to be used, and that means that anything above info will not go out to standard out. And that's good because we've got everything in warning and above going to standard error. Okay, so let's configure our logger using that JSON that we've just created, and then we run it, and lo and behold, we get no duplication. Oh, we've changed the formats. I've called the formats now O format and E format, because you can just call them anything you like, and this time I'm starting O with O and E with E, because O is going to standard out, E is going to standard error. Alright, now you need any more explanation on that? I think it's probably clear. Alright. Now let's do some more in bash. Now I want to create a virtual environment, which is, as you saw before, without the virtual environment you get all these third-party libraries that you don't want. But in Ubuntu I have to install this Ubuntu package first, called python3-venv for creating virtual environments. And I could do this with the exclamation mark, or I can use the %% bash to do it. So let's use %% bash. Alright, now that's installed it. All and with errors. So, well, let's let's run this command and see if it actually worked enough for us to keep going. So what we're going to do here, and this time I have to use %% bash because I've got 3 lines that I want to run. I want to create the virtual environment, which I'm going to call venv194. I would need to activate the virtual environment, and I would need to run all the commands that are going to be in that virtual environment. And so it's all in bash. Okay, not looking good. Was not because ensure pip is not available. You need to install python3-venv. Alright, so let's try a different way. Let's try this one, python3.10venv. And I'll also do it using the exclamation mark. Okay, that didn't work either. So let's try there's another one that might work, virtual env. Okay, so let's try with virtual env rather than venv. So this did all work for me when I tested it. Ensure pip is not available. Alright, I don't use virtual env much, but we might be able to use that. Okay, so that looks pretty easy. Let's try that. So rather than that command for creating the virtual environment, we'll use .194. Okay, and let's have a look. Should be there, venv194. Let's hide this command because that's what's causing the problem. Actually, we'll just I'll get rid of the output. We'll create a new one here, and %bash. Now the virtual environment is created. We should be able to activate it, and it's just the same way of activating. So source just means we want to run an executable. Yeah, that's where it is, in the bin directory. Yeah, there's a bin directory there, and we're going to activate. No such file or directory, and that is very weird because I'm pretty sure it's going to be in there. If I look in bin, it's not there. So sorry about this, because I can't actually go any further if we can't get a virtual environment going. Oh, maybe I can. Maybe let's just do it without virtual environments, which is a shame. So we'll go. Okay, so we're going to create a Python app that we can run from the command line. And we're going to, what have I missed here? Activate it, install those things. So they're already installed, so we're okay. So this time I'm going to create a file. And remember last time I used the redirection, I used the greater than sign just to create a file called logdemo.py. This time I'm going to use the program called T. And what T is it takes any information. Oh, I'm going to use a pipe first. So that takes anything that came from standard out from the cat command, goes through the pipe, and then into another application as standard in. And the application we're going to use is T, which can then save it to a file. So it's pretty similar to the greater than sign, but the advantage of using T rather than greater than sign is that you can elevate privileges on T. So I could do sudo T, where you can't do sudo and then the greater than sign. So you'll find T used quite a lot. We don't need to use it here because we're not sudoing. We could just use the greater than sign. But let's just see it happen. We're not going to activate any virtual environment because they're not set up that way. So we'll have to comment that bit out. And then we're going to run the demo. So there's the file we've just created. Then we've got the demo logging tree output. It's run, and then it's run this. So if we look at the code, we can see I've got if the logger is enabled for debug level, then do a printout. So this is how I can use the logging levels to actually control other pieces of code. And this is also useful if something in developing your logger message is takes a long time. So you only really want it to run when you're logging. So if you're not logging, you don't want it to run at all. So you can use an if statement, and logger is enabled for that level to stop it from even calculating what needs to be logged in that situation. All right, so we've got our logger. It's got and we're going to send the outputs, which we have, and for some reason it very nicely didn't use the main Python, which is great. So I think virtual env has actually done what we needed, and I can check that. I'll go which Python 3. Oh no, that's the other one. But anyway, this is, let's do a %% bash and see if that's the same thing. Yep, I don't know what's going on, but it looks like if I do, well, let's do a pip list. Yeah, it's still got all the libraries. But anyway, our logging tree printout just printed out our root logger and our main logger and none of the other libraries. So that was great. And it's showing the output messages, and there's nothing else. Oh yeah, it's showing that standard error and standard out are both going to the console. So you can see they're the standard out ones, they're the standard error ones. So change the root logger to info not debug. Okay, so we can do that just in our config file. And the root logger is here, and we've set the level to info, not debug. And the one thing that's slightly different here is because T sends the output to both the standard out and to the file, we don't want to actually see the standard out for this command, so we send that off to dev null using this redirection, and that means it only goes to the file. So you can see that when we run this, we don't get any output. It's just created a new file, and we can now run, and it'll use that new logging configuration. Both standard out and standard error will go to the console, but we don't have any debug, so that's good. Now we want to redirect the standard out to a new file, overwriting it with the greater than sign. So let's see what happens when we do that. So I'm running a Python program by calling Python3 and then the name of the script that I want to run, and I'm using the redirection in bash to send the output to a file called demo.-standardout. You can see there's no file there called demo.standardout, but if I run it, you can see that standard out didn't come to the console. All I got here was standard error, all the E's, but I didn't get the O. And if I look over here on the left, eventually, I'll just refresh, I get a file called demo.standardout.txt, and I can look up there and I say, there's my logging message, it's there. So I've done that. Even though the logging configuration is set to send it to the console in standard out, I've used bash to say send it to a file instead. Alright, so now I can do the same thing with standard error, and to do that, for the in front of the greater than sign, or double greater than sign as we'll use in this case, you put the number 2, because 2 refers to standard error, 1 refers to standard out, but it's default, so you don't actually need to type it in. So if I run this code here, nothing comes to the console, but you'll see over here I get a demo standard error file which has got those 3 lines in it, and the demo standard out, and because this time I used double greater than sign, it's appended the new message to the old message, which are the same message both times, so now I've got it there twice. And what are we going to do this time? So we want to redirect standard error to where standard out is going currently, which is to a pipe. Then I want to redirect standard out to the files demo.standardout.txt, and then I want to pipe into standard in of t to create a t'd standard error. And so to do that, to redirect standard error to where standard out is currently going, I use to, which is standard error, redirected to, and I can use this &1 to say a copy of what is currently standard out, and standard out is what goes through this pipe to go into as standard in to the t function. So we'll just hide this source command again and run the bash script, and there we go. So we've now created a new file called t'd standarderror.txt, and you can see what's in t'd standarderror.txt just by looking at the file, and you can see that that's the new everything that was going to standard error has gone to t, which means that t is saying go to the console and go to the file, and we can see it there in the file, and we can see it there in the console. So are there any questions on that? I hope you enjoyed it. I hope you learned something from it. Remember, next week we've got pizza at the Brisbane Business Hub, so I'd love to come along. And the week after that we're doing a Christmas party, so yeah, register for that and come along so that we can all just have a social occasion with no learning required. Okay, see you later.